right, so we're going to have a look at how we can form, essentially today what we're going to look at is the general term or the general rule. Sorry, I'm trying to decide how big I want this. Alrighty, so if we look at this first pattern, if we look at this first pattern, my first question to you is, don't look at the questions, don't look at anything. Look at the number pattern that I've given you, which is this one up here, -1, -2, -3, -4. And in the chat, all I want you to do is essentially describe the pattern. What are you doing to get from one term to the next? So have a look, have a think, what are we doing? Good, grade 8s, well done, excellent. So you can either say that you are subtracting 1, which I'm absolutely fine with. 1 or 2, that's not how you're supposed to subtracting. 1 or 2 of you have said that you are adding -1, which is absolutely fine. Adding -1 is the same thing as subtracting 1, that's fine. So we can see that. We are going -1, -1, -2, -2, -1, -3, and so we keep going. So if we go and now essentially fold this information into our table, we can see if we look at the position of the term, so this first row, the position of the term is the first term, the second term, the third term, and so we keep going. So position is which term is it in the sequence? First, second, third, 10th, 20th, what is it? All right. Now, if we translate what we already know to this table, we have got the first 4 terms. We don't have to think too much about that. We know that the first term is -1, the second term is -2, the third -3, the fourth -4. What we don't have, though, are the next 3. So I want you to think about what the pattern is, and in the chat, write down the 5th, 6th, and 7th terms for me. You can write them all as one list. You don't have to send them separately. Go one by one by one.
I'm loving this class. Well done, guys. Well done. We love people who listen to instructions. Y'all are amazing.
Right, excellent, guys. So we just keep subtracting 1. We get -5, -6, -7. Excellent, well done. All right, so what is a new sort of question is this question that I have in C that says determine a formula for T of n. Okay, now we've never seen this before. Some of you obviously might have seen this before because you might have done this at school. But in terms of what you and I have done together at Watobe, we have not spoken about this before. Now, this is not hard, right? If you listen to my words and you listen to what I'm saying to you, I promise you it's not hard. We know, as it currently stands, that if we wanted to find a general formula or a rule for my pattern, we have been working in terms of X and Y, in terms of X being the position, Y being the term in my sequence. But mathematicians are mathematicians. We use a very specific set of variables or set of representations in the number pattern section. So the position of the term is represented by n. You can see that here. So n represents the position of my term. And the value of my term is represented by Tn. Okay, so the general term, or we can sometimes call it the general formula, is represented by Tn, where Tn is the value of any term in my sequence. So it's like the Y value, right? That's what we said Y represents. It's it's actually basically the same thing. We're just now using Tn instead of Y. Right, so what that means is T is term, N is position. So term in position, whatever. So just a reminder, n is the position of your term. I've put that up in the table, but I'm just going to write it down anyways. So is it the first term, the 7th term, the 21st term? Where is it in your sequence? What this means and what this notation or this way of representing terms allows us to do is it allows us to sort of write term values in quite a concise way. So for example, I could say term 4 is equal to -4. What I'm saying is from my pattern, the 4th term is or has a value of -4. So this T4 equals -4 is saying that the value of the 4th term is -4. Right? So there's the 4th term, because remember that little number at the bottom is n, and whatever that whole thing is equal to is the value of my term. So if I look, say, for example, at these two values, this is saying that the 6th term, so term 6, has a value of -6. So that is what Tn and n essentially represent for us. They represent a value of a term and the position of the term. It's very similar to x and y. We've been using x as the position, y as the value. It's very, very similar. We just are using different variables to represent x and y now. Now, the reason that we are going to talk about this and the reason that we need to get used to this is because if you plan on taking maths grade 10, 11, 12, in number patterns, we only use Tn because we can write it in the short form, T4 equals -4. We can use it when we start to find formulas and start substituting. So it's very important that we're comfortable with this. Okay, so if you want to find a general formula, you do exactly the same thing as what we were doing when we were using x and y. If you have no idea what I'm talking about, Monday's lesson, you need to go and rewatch or go and watch for the first time. All right, so because I've said this is exactly the same thing as using x and y, let's go and think about that, right? So if I asked you to find the general rule in terms of x and y, we know that y is equal to, and we start by multiplying x by whatever we're adding or subtracting. So we're subtracting 1. So we need to say -1 times x. Now remember, this next thing that we do is we double check and see if there's anything I need to add or subtract. Whoops, sorry. So to check, I need to go back to my values. So I've got an x value, remember, x and y. I've got an x value of 1 and a y value of -1. So if x equals 1, I want my y value to be -1. Let's double check. Y is equal to -1 times 1. I'm replacing the x with a 1, and that gives me -1. Look at that. That gives me what I wanted. If we just do another check, just to, make sure that I am actually on the right track here. If I now go to my next value, I've got x is 2 and I want -2. So let's just say x equals 2. I want y equals -2. I substitute in y is equal to -1 times 2. And look at that, -1 times 2 is -2. I got what I wanted. So what that's saying to me, remember, is that this rule that I've just found of y is equal to -1 times x does apply to my pattern. But I have said specifically in this question, determine a formula for T of n. But we know that T of n represents the value of my term and n represents the position of my term. We can interchange them with x and y. So I could now take my rule that I've just found and I can write this in terms of Tn and n. Tn is the value of my term, and the value of my term is equal to -1 times the position of my term times x, which is n. So if you have a look, basically all you are doing is you're translating the fact that we know that y is the value to represent Tn, and n, or x rather, is your position of your term, which is now represented by n. So Tn and n are the same thing as x and y. We're just using different variables now. So our rule, our formula for T of n, I'm just going to write it without all of these colors here, is T of n is equal to minus 1n. If you want to just say minus n, that's also absolutely fine. But you get your sequence. If we go and have a look at what I wrote down earlier, just to prove the point here, I'm running out of colors. So I wrote down earlier, term 4 is equal to negative 4. So here I'm saying n is equal to 4. Let's see what happens when I substitute n as 4. So Tn is equal to minus 1 times 4. Look at that. I get negative 4. So I can see that term 4 is in fact negative 4 according to my rule. So the rule is the same thing as y equals something happening with x. We're just now using Tn and n. All right, I'm going to stop. I'm going to let you take screenshots. This is also the point where if you want to, if you want to ask me questions, now is the time to raise your hand and ask. We are going to practice more grade 8, so don't stress, don't panic. We're going to do more, but now is the time if you would like to ask me a question to do so. No questions. Good, grade 8s. Remember, if you do have questions while I'm explaining something, you always just put it in the chat. All right, I'm just waiting for everyone to take screenshots. Hopefully you've all done that. Okay, guys, good. So let's practice, right? This is what we need to do. Patterns we need to practice. Okay, before I carry on, Ria can say, yes, you have a question. You can raise your hand if you want, and then I can unmute you, or you're welcome to put it on the chat. There we go. You can unmute yourself.
Ma'am, is it fine if you say Tn equals to term number times n?
Term number. Why would you say term number times n?
Because ma'am, at our school they say that you say you write Tn equals the term times n.
I don't know if maybe I'm just misunderstanding, but it's not going to work. So if you look at our example here, if you say Tn times n, what you're essentially saying, okay, in this case, no, actually this will work. So if you say Tn, which in this case, if we have a look here is negative 2, and we times it by n, which is 2, negative 2 times 2 is negative 4. That's not part of our pattern. So I might just be misunderstanding what you have been told at school. Obviously, if you've been told at school, it's probably fine. And often people do these patterns a little bit differently. Just my suggestion, you can say, is just keep checking that you're getting the same answers as me. If it's working, then that's absolutely fine. All right. So let's have a look at an example. So first thing that I just want you to do is have a look, and in the chat, tell me what you are adding or subtracting each time. There was a question at looking at constant ratios and number patterns. We have done some examples like that. We focus more on these types of patterns, which we call linear patterns. So no, not really, but we have done some examples in, I want to say, the first lesson. So you can go and rewatch the first lessons video and you can see those. So remember, guys, I'm asking you, what are we doing to this pattern? Good. Just some of you, I need you to double check. Are you adding positive 6 or are you adding negative 6, i.e. subtracting 6? Okay, good. Okay, so guys, we can see that in this pattern, we are subtracting 6. Whoopsie daisies, my mouth just ran away from me. Excuse me. So positive 5 minus 6 is negative 1. Negative 1 minus 6, negative 7. So we can see that. We're happy. The question is asking us, I didn't even ask you to look at the question, I just asked you to tell me the pattern. Question is asking us to find the general formula. So I want Tn, essentially. Now, let's have a look. If we go back to what we spoke about here, Tn is basically the same thing as finding our algebraic pattern in terms of x and y. So let's follow the same rule. Y is equal to, so Tn is equal to, and we times x, so we times n by whatever we're adding or subtracting. So we can see that that's negative 6. So I'll say negative 6n. And then we always want to double check if there's something that I should add or subtract in order to get the output that I want. All right, so we need to do a check here. If we just draw a very, very rough table here, remember we're concerned about the position of our term, which is n, and we're concerned about the value of our term, which is Tn. The first term is 5, the second term is negative 1, the third term is negative 7, and so you could keep going. I'm just going to do the first 3. It really doesn't matter. All right, so if we now go back to our rule, we want to check if there's anything I need to add or subtract. So let's start with the first term. This is telling me that if n is equal to 1, Tn must be equal to positive 5. So let's use our rule. We've got Tn is equal to minus 6 times n so far. Minus 6 times 1 gives me, whoopsie, don't know what's happening, gives me negative 6. Now remember, we have just said that we want this to be equal to positive 5. So our question is, how do we get from negative 6 to positive 5? What do I need to add or subtract? Now, this is where maybe a number line is quite useful. Some people it's useful, some people it's not. I'm hoping I managed to draw a big enough number line this time. So we're at negative 6. We need to get to positive 5. Good, Tito. Good, Awamba. Nice, guys. 2, 3, 4, 5. Okay, my number line went a bit weird. So here we are at negative 6. We need to get to positive 5. I add 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I know that to my rule, I need to add a plus 11. Now remember, guys, once we've got this, you're probably right. I can tell you that right now. However, maths, we always want to just double check ourselves. So let's double check by looking at our next value, where if n is 2, t of n must be equal to negative 1. So now we use the rule that we found. Tn is equal to minus 6 times 2 plus 11. Minus 6 times positive 2 is negative 12. And negative 12 plus 11 is negative 1. I got what I wanted, and so my rule that I found is correct. Okay, so it is the same thing as using x and y. Exactly the same thing. We do exactly the same method. Nothing changes. I'm just now using Tn instead of y and n instead of x. Now, just on a very quick side note, because I saw a couple people put this in the chat. A few of you in the chat gave an answer of T of n is equal to n times -6 plus 11. That is fine. We always try and simplify. So we would always try and multiply the -6 in the end to get -6n and then plus 11. However, it is fine. It gives you exactly the same thing. It is exactly the same as -6n plus 11. So if you wrote n times -6 plus 11, happy days, well done. You are on the right track. Right, I'm going to stop here for screenshots. You guys have done amazingly. So you definitely deserve a brain break today. We're going to take a little brain break before we carry on with another example. And guys, seriously, like, you can ask Yolanda, I was not feeling very happy with the grade 8s in general after the last class. I love them, but sure, I don't know if I'm just having a bad day. And you guys have really done amazingly. So well done.
Well done, guys. Really, you are behaving. I love it. Well done, guys.
Okay, just quickly, Luandle's asked, is there a constant difference? This is exactly what we're looking at, Luandle. So because I'm always subtracting 6 in this case, or if I'm adding or subtracting the same thing, it is remaining constant. And that is essentially what a constant difference is. So here, whatever, this -6 is what we call a constant difference. If it was +6, it would still be a constant difference. All constant difference means is that we're adding or subtracting the same value to get from one term to the next. That's all that means. All right. I hope you've all got your screenshots. Brain break, which is very much deserved by you guys. I don't know how big I can make this. Let me just...
The joke, guys. No, we can see it perfectly. The joke. What is a bird's favorite kind of math? Algebra. Love it. I love it, guys. Let's go. Let's see who's going to get the correct answer, the final correct answer. We are 90 of us. Let's see. Whoever gets it first, I already know the answer. I know I cheated because teacher Sam fed me the answer. No, Didintle. So how we do it here, you will have to put it on the chat. If you get it right, I'll call your name and then you can raise your hand to explain to the rest of the class how you got it, okay? So it's a sort of a competition. Let's see who is the winner of today's brain break. And I'm so happy that you guys behaved and you deserved a brain break. I'm so happy. Nope, not 7, not 75. Unless if the 7, I mean, it's not the final answer, of course. It's not 75. So we're only looking for the final answer. You are more than welcome to just calculate your answer first before, and then when you get the correct answer, you can definitely let us know. So let's see. I want to see. It's not 221. It is not 221. Let's see who else is done. Just put it on the chat. I'll definitely let you know whether you are right or wrong. And if I don't say anything, it means that you are wrong also, because whoever says it first, I'll definitely call out your name and I'll celebrate with you. Let's go. So this is more like algebra, right, my people? You're doing it just like algebra. Nope. It's not. Wow, that was so fast. Wow, wait. Over there, Rinelwe. Where are you? Oh no. Rinelwe, please raise your hand. Raise your hand so you can explain to the class. Well done. I'm so proud of you. You got it so fast. Okay, everyone, thank you for your effort of trying. Rinelwe got it first, so Rinelwe is going to explain step by step. Remember, this is supposed to be fun, so please don't get offended. We really appreciate you trying. And next time, definitely, it's going to be you, the winner of the brain break. Rinelwe, go! I'm celebrating with you. Oh boy, I don't know. Hi.
Hi, ma'am.
Hi.
So, ma'am, the wheels are 7.
Okay. Good. So 7 plus 7 plus 7 is 21. What about the next one?
And then the leopards or its cheetahs, they are 10.
Good. Now, guys, remember, when you've got multiplication, or multiplication and addition, the multiplication has to happen first. So 10 times 7 is 70, and then 10 plus 70 gives us that 80. So that's why, or how Renilwe got to 10 for the, I don't even know what animal that is, cheetah, leopard, big cat thing. Okay, next one, Renilwe.
And then ma'am, if 10 times 10 plus 20.
Okay, good. So guys, now we've got two cheetah leopard things. So that's double 10, which is 20. And then we know that these bison things, whatever, are 10. 10 times 10 is 100 plus 20, 120. Good. And then the last one.
And then in the last one, it is 5 plus 20 because the leopard they are 2. And then it is multiplied by 7.
Good. Now, what should we do first? The multiplication or the addition?
The multiplication.
Good. So, guys, 20 times 7 is 140. So, Renilwe, what's the final answer?
145.
Good. 145. All right, now guys, just quickly.
Well done.
This bison thing is 5 because there's only one of them. Here, you've had 2 that gave you 10. So half of that gives you what 1 is worth. Very nicely done. Excellent. All righty, grade 8s. So you're going to find the general term of this next formula, very exactly the same as what we did in the first question. And what I'll even do is I'll leave it up for you like that. I want you to look at the second one, which is a pattern of 0, 3, 6, 9. And I want you to, again, find the general formula or the general term for this pattern. So have a think, have a try. As Thanduwetu said there, think about what the pattern is. If you know what the pattern is, so if you know what you're adding or subtracting, that is your starting point. Again, guys, I don't want you to describe the pattern. I want you to find the general formula. So remember, the general formula is this Tn thing. That is your final answer. Your final answer must be Tn is equal to something. That is what I'm looking for. Good, guys, keep those answers coming. I'm going to give you another minute or so. Always double check whether or not you need to add or subtract something to your answer. That's very, very important. Lunofefe, I know that you're not the only one struggling. So the question is it possible to write the quiz tomorrow because the network's quite bad? Yeah, guys, the quiz is available, and Yolanda can correct me here if I'm wrong. I'm pretty sure for the whole week until the next quiz comes out. You need to do it, I think, by Friday in order for us to get your results. But you're more than welcome to. We get that network's a problem.
Yeah, so you will definitely, if you log in tomorrow, whenever there's network, you will find your quizzes there, okay? Under today's lesson, there should be a quiz there. So once this gets uploaded by tomorrow, then you should find it maybe around 24 hours. So around 4, around 3, I'm not quite sure, but when you come back from school, just have a check and then you can do your quiz, okay? So please don't stress about that part.
Good, grade 8. I'm liking what I'm seeing. Alrighty. So would anyone like to raise their hand to explain to us how they got the answer that they got for this general term? Oh, sorry. Chantal, would you like to explain?
Good afternoon, ma'am.
Afternoon.
Ma'am, I got what is that 3n minus 3 by saying 3 times 1 is equals to 3
Good.
minus 3 is equals to 0.
Perfect. And that's what we want for the first term.
Yes.
Excellent. Well done. All right. So guys, Chantal very nicely explained there how we can also double check that our rule or our general formula is correct. So as all of you told me, you were adding 3 for this pattern. And so you automatically know that this is Tn is equal to 3 times n. We want to just make sure that we're not adding or subtracting anything here. And this is now what Chantal just explained to us. If I go and do that check for myself, and I've got, or I use the first term, I don't know why that pen is so excessively thick. Let's just sort that out before I carry on. If we do that, if n is equal to 1, we want our Tn value to be equal to 0. So exactly as Chantal said, if I substitute n is for 1, I end up with 3. I don't want 3, I want 0. And so what that means is I still need to subtract 3 here in order to get 0. And so that's why in the pattern, we've got minus 3. You can always double check yourself if you want to. If you're not feeling super confident, you just do a quick check for yourself. If we did n is equal to 2, we want Tn, if you have a look here, to be equal to 3. So Tn is equal to 3 times 2 minus 3. 3 times 2 is 6. And 6 minus 3 is 3. That's what we wanted Tn to be. So we know that this rule that we found is correct. Very, very nicely done. Just going to wait there in case anyone wants to take screenshots of that. I'm also going to wait. Oh, crap. Oh, sorry, I didn't say that. I'm also going to wait in case anyone wants to ask me a question. So if you would like to raise your hands to ask questions, now is the time to do so. Right, Lwandle?
Afternoon, ma'am.
Afternoon.
So, ma'am, my question is, how did we get Tn equals 3n minus 3? Because at school, right, they said Tn is equal to A plus opening brackets n minus 1 multiplied by the constant difference, which is D.
Okay,
so now I tried using that formula, but I ended up getting 6, which was the second term.
Right, you should get the same thing. So I'm choosing not to use the formula just because we're really starting off with this. However, if we just take that quickly, the formula that you're using at school is, Tn is equal to, what do you say? A n minus 1, no. A
yes,
plus,
you're correct. A plus n minus
n minus 1 and then times D. Okay, so what does A represent?
The first number in the pattern.
Good. So this is your first term.
Yes.
D, as you've already told me, is your constant difference.
Yes,
okay, so your constant difference, right? We got the n. So our first term of this pattern was 0. We've got n minus 1, and our constant difference was 3. So remember, you need to distribute that 3 into your bracket, and that gives you 0 plus 3n minus 3. the 0 minus 3 just ends up being minus 3. So you end up with exactly the same thing.
Oh, now I get it.
Okay, so yeah, like this is the formula we're eventually going to use. But because this is like the start of number patterns, I'm choosing not to do that. But yeah, go for it. I use this one all the time.
Okay, ma'am, thanks.
Cool. There was a question about, is it necessary to be able to write a rule in words? Yes, in grade 8 and 9. So these questions that I had earlier where I said describe the pattern in words, sometimes you're asked to do that. However, even grade 9, from that point, we don't really ask it anymore. So yes, it's necessary. What I feel is more necessary is that you can look at a pattern and you can see what you're adding or subtracting each time. Oh my gosh. Okay, so know how to describe it in words. So know that you need to be able to say I'm adding 3 each time or whatever, but don't stress about it. It's not going to become the focus later on with number patterns. So make sure you can do it, but also don't have sleepless nights about it. Right, guys, I'm assuming no more questions. Again, those of you that are feeling you need to catch up on work, that's cool. All the videos are there for whatever reason. That's all right. Can't do the quiz tonight? Don't stress. Alrighty. So let's have a look at a situation where our pattern is represented with pictures. Alrighty, so here we've got our pictures. We've got picture 1, picture 2, picture 3. What we want to do, and what I like to do, even if the question isn't asked, is I always like to write the pattern with numbers. I don't know why, for whatever reason, me looking at this picture, I can't easily see that there are 6 matchsticks in the first picture. And then I don't even know how many are in the next picture. I have to count. So for me, writing it out is a little bit easier. And that's what we're going to do in the table. So the table's got picture number 1, 2, 3, 4. So this is picture 1, picture 2, picture 3, etc., etc. And then the number of matchsticks. I feel like that's quite self-explanatory. So if we look at picture 1, there are 1, 2, 3, 4, 5, 6 matchsticks. So that's what we're going to write over there. Picture 2, we've got, I don't really want to have to write all the numbers, but let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 matchsticks. Right, so I want you to quickly in the chat write down for me how many matchsticks there are in picture 3. Picture 3. Good, grade 8, there are 16. Right, now the table has got picture 4. But obviously, we can see we have no picture 4. So let's just stop for a second and let's establish what our pattern is. So what is the pattern? If I go 6, 11, 16, what am I doing to get from one value to the next? What is my pattern? Good, guys, we're adding 5 each time. So we're adding 5 matchsticks to get from one picture to the next. 6 plus 11, 6 plus 11. 6 plus 5 is 11. 11 plus 16 is 11 plus 5 is 16. So quickly for me in the chat, what is 16 plus 5? How many matches am I going to have in picture 4? Good, grade 8. We will have 21 matchsticks. Okay, so often what we like to do in these sorts of questions is either ask you in like a table format how many matchsticks will be in the next one. What we also like to do, and I don't know why we do it because it is such a mission, is sometimes we ask you to draw the next picture or the next pattern. So if I had asked you to do that, for example, try and make your life a bit easier. you can see that you've already got the first three. So I would just draw the first three, and it doesn't have to be a beautiful piece of art. Like this isn't art, it's maths. And then you just add on the next sort of picture to that. So sometimes we do ask you to draw, so be prepared to draw the next picture. That is definitely a question we like to ask. But yeah, I think you can all draw the next picture. Okay, so the next question is asking, and we're not going to panic. We're not going to be overwhelmed. It says, determine a rule. So the second we see rule, we're thinking TN. For the number of matchsticks needed in the picture P in the form M equals. Now let's not panic about in the form M equals. In the form M equals is saying the number of matchsticks, which we know is TN, in terms of the picture number. So essentially they're asking us for TN equals blah, blah, blah. We'll sort out the M and the P in a second. Let's just get our rule. So 2 minutes, guys. Tell me what the rule is for this pattern. You can use TN. If you're comfortable with this and you can already write it in terms of M and P, that's fine. But start with TN. Let's start there, and then we'll have a chat about what this means. Ow. Right, remember your TN rule, it's not just +5. There's an algebraic rule that we need to be working with here. Good, guys, well done. So we know that we start by saying whatever we're adding or subtracting times n. We always double check whether or not we need to add or subtract anything to that. So if I just do a very quick check, if I take the 1, I know I want an output of 6. So 5 times 1 gives me 5. I still need to add 1 to that to get 6. So that's why my rule is Tn is equal to 5n plus 1. Another question asked me to do it in terms of M and P. So let's just go back to our table. M is the number of matchsticks, and we know that that is represented by Tn. So instead of writing Tn, I write M. P is the picture number. The picture number is what was in my top row of my table, and we know that's represented by N. So in place of N, I'm going to write P. And so then I just fill in the rest of what I know. M is equal to 5P plus 1. It is exactly the same thing. I'm just writing it in terms of M and P. So our rule here in the form they wanted it is M is equal to 5P plus 1. All right. I also really like number patterns. It's one of my favorite sections. It's also a section where we can get quite creative, and I don't want to say ask problem solving questions, but we can ask some really cool questions in this. And so you'll see if you do maths grade 10, 11, 12, we can get some really, really cool questions. So I also really enjoy this section. It starts off quite hard, and it's quite hard to understand in grade 8 and grade 9. Once you get it though, easy marks. All right, guys, I'm gonna wait there in case anyone needs screenshots. I'm also gonna wait in case anyone has a question for me. You can raise your hand. That's what I mean, so sorry. So if you have questions, you can raise your hand. Otherwise, you can see on the chat, Yolene just posted the quiz link. Again, if you need to go back and rewatch videos, which I highly recommend you do if you're feeling a bit confused, do that before doing the quiz.